Okay. In previous class, we were studying these communication criteria. In these big topic, there are again some sub topics are there in which we were already completed range. Okay. Then also we have completed frequency bands. Then we have completed power consumption also. Then we were here, that is topology. So here there are three types of topologies are there in IoT networks. Okay, to connect these IoT devices, we need this topology to construct a or to develop a IoT network. So here basically three types of topologies are there: star topology, mesh topology, and peer-to-peer topology. In last class already I have shown you the diagrams of these topologies also: star topology, mesh topology, and peer-to-peer topology. And I already briefly explained about these topologies by giving our college example itself. Here these nodes or whatever they are appearing here, these are called as full function devices. Full function devices, it means they have more works or more load. Okay. And here these nodes are called as less function devices or reduced function devices. So here this first one, star topology. This is star topology is very much suitable for long range technologies as well as for short range technologies. And the one beauty of this star topology is, in fact, it can be used for medium range technologies also. Okay, since it is suitable for short range also and long range also, obviously it is suitable for medium range technologies also. Okay, so for short range, the examples are Bluetooth technology. Okay, so for long range, the examples are cellular technology or low power wide area technology, that is LPWA technology. So if we come to this star topology, basically how it looks like, it uses a single central base. It uses a single central base station, and over all these single base station only, the remaining all endpoints are connected. Okay, so for medium range technologies, this star topology, already I told you that star topology is suitable. But apart from star topology, we can use a peer-to-peer topology also, or else mesh topology also. Okay, so for which range technologies? For medium range technologies. Then peer-to-peer technologies always they allow, so any two devices or more than two devices to communicate with each other if they are in their own range. Okay, if the devices are in their own range, then these peer-to-peer topologies are allowing those devices to communicate with each other. As just now I told you, this peer-to-peer topology is suitable for medium range. Okay, so then obviously these peer-to-peer topologies are dependent on a multiple number of full function devices. If you look into this topology diagram, so here these all maximum number of nodes are, which type of nodes are here? These all are full function devices. So they allow the communication between multiple number of full function devices. And these peer-to-peer topologies, they are actually set of networks or set of topologies they are. Okay, so then what are those sub networks? What are those topologies? Those sub topologies are nothing but they are mesh topologies, because n number of mesh topologies are, or n number of mesh networks are together connected, and then that entire, the whole topology or network is called as peer-to-peer topology. Since peer-to-peer topology is creating a complex formations means so difficult or somewhat complicated layout of a network, not a simple like star topology. So usually it is a collection of mesh topologies. If you observe here, so in this mesh topology, this full function device is connected to one more full function device, one more function device, like this multiple number of full function devices are connected, right? So these all connected multiple function devices, if you consider, then it will create a peer-to-peer topology. Okay, so here one example is Suppose if you are considering a big company or big building, in that large building, the indoor wi-fi devices, how we are deploying uh, these in indoor devices, wi-fi devices are deployed in the form of a star topology. And the outdoor, outside the building, in the campus, these topologies, these devices are connected in the form of a mesh topology. So for example, if you consider our campus itself, in the main building we have wi-fi devices. In the indoor, if you consider, these all wi-fi devices are connected in a star topology. And if you consider the library building, there also wi-fi devices are connected in a star topology. And boys hostel and girls hostel, again four buildings are there. Okay, if you consider these four buildings, in all four buildings, these indoor wi-fi devices are connected in the form of star topology. And again these four buildings are connected in the form of mesh topology. So here these all access points are connected in the star topology in the inside the building, and outside the building they are connected in the form of mesh topology. Okay, so then mesh topology requires implementation of layer 2 or level 2 forwarding protocol. So there are categories are there, protocol categories, level 1, level 2, or layer 1, layer 2, layer 3, layer 4, like this. In that one, to implement this mesh topology, particularly which protocol we want layer 2 forwarding protocol. And usually this layer 2 forwarding protocol is called as mesh under protocol. Remember, these are all technical words. Okay, so these type of words only we will be expecting in your answers, so when we evaluate your papers. Okay, so to implement mesh topology, we require layer 2 forwarding protocol, which is usually called as mesh under. And also, if layer 2 protocol is not available, then we can go for a layer 3 forwarding protocol, usually what we call it as a mesh over. So as its name itself is, layer 2 is a mesh under and layer 3 is mesh over. Any one of them is required. Okay, not both. So these layer 2 forwarding protocol are called as mesh under, and then or we can use layer 3 forwarding protocol, which is called as mesh over protocol. Okay, so then let me to go to next subtopic, that is constrained devices. See, these are the devices with constraints. As its name itself is a constrained means what? Somewhat limitation is there, somewhat restriction is there, and somewhat conditions are there. Okay, so some limitations are there. The devices which are having the limited specifications are called as constrained. It is a general meaning. And if you want to know the actual meaning of constrained devices, they are also nothing but they are end nodes. So you know, in star topology you had one central base station, right, to which all endpoints were connected, right? So here in constraint devices, the constraint devices are nothing but these end nodes which are embedded with the sensors and actuators. So these nodes are having sensors or actuators, and these end nodes or these constrained nodes are going to handle some particular or specific applications. Okay, particular applications. So categorizing or classifying our IoT nodes or IoT devices based on the computing speed or computing capacity or memory capacity, storage capacity, power, and networking. So if we want to classify them based on these parameters, then it is very difficult for us. So Wasser, why you are telling me these all things? Because why I wanted to tell you constrained devices. Constrained means they are very much limited, they have a very much a small specification. Okay, so here we are having these computing, memory, storage, and power, and networking. These all we can do in a large machines or big computers or any other machines, big computers. But here I am talking about which devices? Constrained devices, which are very small in size and which use very less amount of resources. It may be computing speed, it may be memory, it may be storage, it may be power, and it may be networking. So here memory is there and storage is there. It means that it is a RAM and it is a hard disk, that is secondary storage. Okay, so constrained nodes versus unconstrained nodes. So whatever the devices we are using in our IoT networks, they can be divided into constrained nodes and unconstrained nodes. So just now I told you already constrained nodes. Constrained nodes, for example, these are microcontroller, smart devices, sensors and actuators, and other any small computers. See here, word is you can look these type of words here, small computers. So just imagine that these are not large equipments or devices. They are very small and minute devices which require very small amount of resource. It may be power, it may be storage, it may be memory, it may be computing. Okay, so constrained nodes are examples are these all. So you can treat them as these constrained nodes can be embedded in other devices. Okay, now I think you understood. Constrained nodes can be embedded in other nodes or other devices. And then what do you mean by unconstrained nodes? It's opposite, exactly opposite. It means they use the high level or high more resources. Okay, so it may be in the form of power. It may they may consume more power. They may require more storage. They may require more memory. They may have a high computing speed. Okay, they have a high networking capacities. Okay, so this type of devices are grouped together in the category that is called as unconstrained nodes. So examples are servers, desktop systems, laptop systems, and powerful mobile devices like our smartphones. So these all are belonging to unconstrained nodes. There is no any limitation for them. But for constrained node, there is a limited resources are used here. Okay, constrained nodes have limited resources that affect their networking feature as well as their capabilities also. So constrained nodes can be divided into again three classes: class 0, class 1, class 2. See, already we have divided the devices as a constrained and unconstrained, and constrained is again divided into three classes or three types or three categories or three levels of devices: class 3, class 0, and class 1. Sorry, class 0, class 1, and class 2. Okay, see here, these are the categories: class 0, class 1, and class 2. So class 0 devices, class 0 constrained devices. So as its name itself is, it is in the low level. Okay, so it uses only 10 KB of memory, 10 KB of RAM, and it uses 100 KB of storage, that is a secondary storage. To just see how small these constrained devices are. They are just using a 10 KB of RAM and they are using a 100 KB of storage. Okay, that is secondary storage. And also there is processing speed is also 10 kbps. Sorry, 100 kbps. Okay, so if you come to class 1, so these are little greater than this class C, no, sorry, class 0. Okay, so they have more than 10 KB and 100 KB memory and storage respectively. And they are not going to implement, or they are not going to support IP stack implementation. IP stack. IP means what? Internet protocol, right? Which is the protocol for a network layer, right? So these class 1 uh, devices or nodes, they will not support these IP stack implementation. It means that just remember, they will not implement the IP stack. Okay, then come to next one, that is class 2. Class 2 nodes are again higher. They are using again higher resources than these previous two classes. They use 50 KB of memory and 250 KB of flash or any other secondary storage, and definitely they will implement or they will support the IP networks, IP networks or IP protocol. And the best example for this class 2 nodes is our smart power meter. Smart power meter. You know, we have power meters at our house. So they are wired power meters, whatever now we are using. If you consider wireless, then they are called as smart power meters. So in wireless, so they will be having a sensor, and one more device may be present in the office, that is KPTCL or KAB. There they will be keep on getting the reading of our meter. Okay, so best example for this type of nodes, class 2 nodes, is a smart power meter. Okay, So now these all constrained nodes, if we connect together, then it will become a network of constrained nodes, right? So as I already told you, constrained nodes require very limited resources. They use very less amount of resources. Okay, so here some IoT technologies are very much suitable to connect such kind of constrained nodes, and some IoT access technologies are very much suitable to connect unconstrained nodes also. So some IoT access technologies, for example, Wi-Fi and cellular. So where usually we use these cellular and Wi-Fi, usually in our smartphones and laptops, right? So laptops and smartphones belong to which category? Unconstrained category, right? So for your understanding purpose, clearly I have written here. So some IoT access technologies where they are very much suitable to connect the unconstrained nodes. For example, laptops, smartphones, okay, desktop computers. For these all, we use these IoT access technologies, that is Wi-Fi or cellular. Okay, then some IoT technologies are very much suitable to connect only constrained nodes. So those IoT access technologies are IEEE 802.15.4 and this 15.4 next version, that is G with RF, that is radio frequency. Then 1901.2 APLC, low power wide area, okay, and dot 11 AH. These all are IOC access technologies examples which are suitable to connect constrained nodes. Examples for constrained nodes, once again I repeat, microcontroller, it may be smart devices, it may be sensor, or they may be actuators or any other small computers. To connect them, we should use these IoT access technologies. Okay. Usually, these constrained node networks, we call them as a low power and lossy networks. See, their short forms LLN. Okay, so what is it? Low power and lossy network. Because we are talking about a network of what? Network of constrained node. Okay, so constrained node networks are usually they are also called as low power and lossy networks. Okay, so low power in the sense what? As its name itself is, these network devices are consuming less amount of power. That's all. Okay, and what do you mean by lossy? Lossy means there may be some loss of data. Okay, there may be there may be loss of data in this network. So these constraint nodes are also called as low power and lossy networks. So lossy is nothing but suppose if you have a broadband, okay. So there are two types of internet. One example I am taking, okay. So to get an internet connection, there are two options in front of you. One is a broadband connection. One more is a leased line connection. So what is the difference? In broadband connection, what happens? Whatever the bandwidth is allocated to you, that bandwidth can be shared by some other customers or some other subscribers or some other users. If the number of users are more on that particular time or particular day, the whatever the expected bandwidth is with you, you cannot get that expected bandwidth. Your internet speed may be keep on varying based on the number of users. Okay, that is broadband. So what do you mean by leased line? Leased line is nothing but, so one particular dedicated line will be for you only. There will be no any intervention or interference or interfere of any other users. Okay, so your internet speed will be consistent. So these type of networks, constrained node networks, are called as low power and lossy networks. Low power means the devices which consume less power, and lossy means, so because of interference of any other users or any other signals, these networks may have uh, data loss, so they are called as lossy networks. Okay, so here uh, if we want to connect these all constrained nodes in a network, okay, so it means that if we want to connect all constrained nodes together, so particularly we want some special type of protocols, right? So these layer 1 and layer 2 protocols usually we use in a connect in these constraint nodes. Okay, layer 1 and layer 2 protocols. After using these protocols, usually we have to evaluate them. We have to evaluate them whether they are suitable for this connection or not. Okay, by considering some characteristics of those protocols. What type of characteristics? Those characteristics are data rate and throughput, latency and determinism, and overhead and payload. Okay, so characteristics for use case applicability. Characteristics for use case applicability. It means whether they are suitable for apply. Okay, those characteristics of these protocols are data rate and throughput. Data rate is nothing but the data transmission, the number of bits or data transmitted in a particular specified time, that may be in terms of second or millisecond or a minute. Okay, throughput is your actual output is coming in which data rate, that is called as throughput. The data transmitted to you in the destination with which speed, with which data rate. Okay, that is called as throughput. So latency is number of the time taken by the receiver to respond back to the sender or to acknowledge back to the sender. And keep it in your mind, always this latency should be as less as possible in any type of networks. Okay, so then the determinism, don't worry about this determinism, just remember latency. Okay, so then we will see overhead and payload. What do you mean by this overhead and payload? So whenever we send the data to destination or a receiver, that data is divided into two parts. The first part is overhead and second part is a payload. Okay, I think this meeting will end in 10 minutes. After this topic, I tell you to rejoin. Okay. See, overhead and payload. Usually what we transmit in the network, we transmit the data, right? That data is divided into two parts, overhead and payload. So what is the meaning of overhead actually? So the overhead is nothing but the message what you are sending. Okay, your actual message what you are sending, its length and the receiver's address and the sender's address. So many types of different informations what we are providing. So that information is called as a overhead. Okay, so this is a part of data. Then what do you mean by payload? Payload is nothing but your actual message what you want to send to the receiver or destination. Now got it? Okay, come to this data rate and throughput. So data rates are available from IoT access technologies, and these access technologies data ranges are from 100 bits per second to tens 10 Mbps. Okay, 100 bits per second, 100 bits per second to 10 Mbps, 20 Mbps, 80, 90 Mbps also, because it is a tens of megabits per second, that is Mbps. So data rates usually in IOC access technologies will be in this range, small to large. Okay, lower to higher or less to high. So small, lesser data range will be 100 bps and maximum will be tens of Mbps. So for 100 Mbps, one access technology is, and in that access technology, the protocol or what we are using is Sigfox. It is a protocol which is suitable for the small or low data rates. And the protocol for these high data rates are LTE, okay, and IEEE 802.11ac. These all are high technologies. Okay. Then, however, this our actual throughput, our actual throughput means what? This is data rate. It is a capacity of a media. It may be wired or it may be wireless. Okay. What do you mean by throughput? Throughput is nothing but it is an actual output what you are getting. Okay, so it is nothing but amount of data transferred within a specified time unit. And usually the relationship between this data rate and throughput is, so you have a more amount of data. Okay, so your expectation I am telling, okay, you have You expect more amount of data should be transferred to me, but what you get, less amount of data. Okay, less amount of data you will receive than the expected. That is throughput. So always remember, throughput will be always lesser than data rate. Okay, throughput will be generally throughput will be lesser than data rate, and data rate will be higher than throughput. Okay, so because of that, we should understand the bandwidth requirements first for a particular application or for a particular technology. So if you are considering any of these technologies, whatever I told you here, so for that particular technology, you should first understand the bandwidth requirement and the bandwidth requirement of your application also. Okay, so then technologies which are not particularly designed for IoT, for example, cellular and Wi-Fi. Okay, so technologies which are not particularly designed for IoT, because these technologies, what I am telling here, cellular and Wi-Fi, so these were actually not designed for IoT. Before IoT, already they were existing here. Okay, but still these technologies are going to be used in IoT applications. Okay, earlier already we had cellular technologies and Wi-Fi technologies, which were having a more amount of bandwidth requirement. Okay, so whenever in our IoT applications we require more amount of bandwidth, at that time of situations, we can use these technologies easily instead of bothering about these technologies and bandwidth more. Okay, simply already we have these technologies, cellular and Wi-Fi, which are wireless connections with high bandwidth. Simply you use them here in your IoT applications if you want high bandwidth. Okay, so here, for example, in a network, if nodes are having video applications, then okay, so because of this video multimedia, we need high data rate, right? So such type of nodes or such type of applications usually we see in a airport and smart city environments, and for detecting the driving actions or any other events in the public areas through this CC cameras. Okay, so this type of technologies we can use in our IoT applications. Even though cellular and Wi-Fi, we don't treat them as a IoT technologies. Okay, so let us do one thing. Please exit from this meeting and rejoin. I will continue next topic, that is latency and determinism.